My name is Charles Kendrick, and I'm here from Isomorphic Software. I'll try and be loud. Okay. And what we're here to talk about today is how to approach building UI for business applications that require both a desktop user interface and a mobile interface. The current approaches for tackling this usually involve building the UI twice over, once for desktop and once for mobile. And we found a way to avoid this by using a novel approach that you probably haven't heard of, adapting the desktop UI down to the mobile UI. So first off, I want to address some common sources of confusion. Here we're talking about building business applications in an enterprise. So we're talking about custom in-house applications at a large enterprise, or if you're an ISV, then we're talking about applications that you build, that you sell into the enterprise. And when a business application developer looks around for advice on how to build a mobile UI, what they tend to encounter is advice that is targeted towards building consumer UIs. And so we see a lot of business developers trying to emulate the successes in the consumer space. They try to emulate Facebook or Twitter or Yelp or companies like that that have been successful in the consumer space. But the problem is that the enterprise space is very different. First of all, there's a difference in resources and focus. So consumer companies tend to have a single flagship application. Their application is their revenue generator. They can focus the entire company's resources on it. Unlimited attention goes towards this app. In the enterprise, we typically have a whole suite of business applications that we need to build and support. And so we need a way to build a mobile UI with a minimum of effort. The other difference is just the goals and the user behaviors between consumer and enterprise. So for consumer applications, they need to be very, very simplified. The focus is on engagement. In the enterprise, your focus is on productivity, not engagement. So you actually need a lot of productivity features in there rather than a super simplified UI. You want a simple UI for usability reasons, but you need more capabilities to allow people to get their work done. And then in the enterprise, the percentage of people who are on desktop versus on mobile has still stayed with a majority of desktop. In the consumer space, there's definitely a trend towards more people being on mobile, but in the enterprise, there's really just a handful of classes of users that are principally mobile, people like sales reps. It's still, the vast majority of users are still on a desktop web browser when they access a business application. Okay, so just to give you an idea of where we come from, we are focused on building large, sophisticated applications inside a web browser. This is what we've been doing since way back when the current web browsers were IE4 and Netscape Navigator 4.7. You can imagine how hard that was. We've had a lot of firsts. The first ever extranet that was based on HTML5 or what used to be called Ajax, or even before that, just JavaScript, was ours. It was for Philips Semiconductors in 2001, and it was an extranet that allowed their partners and customers to come in, order parts, and manage various parts of that process. We were also the first ever to license to an ISV. That was Informatica in 2003, and that was actually OLAP data cube functionality back in 2003. So we have always been at the cutting edge, trying to push the browser to do as much as it can, trying to move more and more sophisticated business applications to the web instead of having them be installable applications, which are much harder to manage. So to return to what we're talking about today, what are your options when you need to build a business application that has both a desktop and a mobile UI that it needs to have? Well, one of them is that you could use two different web technologies, one that is desktop oriented and one that is mobile oriented. There are a number of vendors that provide a desktop UI framework, and then they also provide a parallel mobile UI framework. What you end up doing if you use these two technologies, you're working with a single vendor, but you still build the UI of the application twice, and possibly also the data access layer and various other pieces of it. You build them twice. So that is something we would consider unacceptable. Another option is you can build a web app for the desktop user interface, and then you can build native apps for the mobile user interface. Now here, depending on the number of platforms you feel like you need to support, you're going to end up building the application twice, 3 times, maybe 4 times. Most organizations would not have the resources to pay attention to smaller platforms like Windows Phone or BlackBerry or emerging platforms like Tizen. So this is, again, building the app several times over. There are technologies that will allow you to build for multiple mobile platforms at once, like Titanium. that comes with caveats, and even if you use a platform like Titanium to cover all of your mobile apps, you're still going to build a desktop web application in some other technology, so you still end up building twice. A third option is that you could take a web technology that is focused on ultralight mobile applications, and you could just use that same interface as your desktop interface. The problem with this is that you end up with a crippled desktop interface. The UI frameworks that have been focused on mobile, they tend to be newer, they tend to be focused on being as lightweight as possible. They just don't have the same productivity features as desktop user interfaces. So a lot of people will see the word lightweight and just consider it a universal good, but it's not a good idea to be lightweight when you're being compared to heavyweight technologies that have a lot more features, a lot more, and can provide a lot more productivity for users. So we're going to do a brief demo here, and the purpose of this demo is just to remind you of the state of the art for desktop user interface. It's easy to forget how many productivity features there are in typical desktop UI. Okay. So this is going to be kind of a whirlwind, just to give you like a quick view of various features that you may have forgotten that are ever present in desktop UIs. So for example, frozen columns and the ability to edit with frozen columns, the ability to freeze columns on the fly. This allows users to get a lot more on the screen. The ability to do inline filtering. Date range filters, especially sophisticated date range filters that do things like allow you to choose relative ranges or absolute ranges, go between the two ranges. The ability to have a pop-up that comes out of a grid that gives you those same capabilities. Really advanced filter interfaces. So this is showing a nested filter where I can actually add additional subclauses and use match any, match all at any given level here. Definitely never seen that in a ultralight UI framework. Grouping, especially grouping on the fly, and especially multi-level grouping. So here, this is multi-level grouping with editing and with automatically calculated summaries. The ability to embed components in the middle of grids and load related records right here inside of a grid. Autofitting in many different flavors. Here we have vertical autofitting to content, autofitting to the data in a column, and then intelligently using the rest of the space here for columns that might have more information. Export. Always a key capability to be able to export to CSV, XML, Excel, PDF if you're trying to export an entire screen. And then finally, at the really sophisticated end of things, components that would let you do stuff like this. Here we are pivoting an OLAP data cube model and drilling down on the fly to load related data. This has drill up, it has charting, but I think we've got the idea. Okay, so, right. That was just to remind you of how powerful state-of-the-art desktop UI is. So what happens, we've seen a few customers get excited about building with an ultralight mobile-focused technology, and what ends up happening is, first of all, it takes a long time. There's some initial progress, which looks really good, but then they end up realizing that they have to rebuild some key features that were present in desktop UI. And so then there's a long slog towards the end of the project. The result ends up that when they actually ship and deploy the application, they get all this feedback from end users about features that are suddenly missing. The grouping and the freezing and the exports that we just saw. A lot of times developers don't realize that the end users were actually relying on these features, and so they get buried under a bunch of feature requests to replicate all these features that don't exist in the UI framework that they were using. And then finally, if the application gets as far as an accessibility review, that tends to be a complete failure. The accessibility is hard, managing the tab order, getting the ARIA markup right, and you find that whole functions are just not keyboard accessible, or the ARIA markup isn't being updated on the fly, and you fail the accessibility review. So all of these options just don't work. We can't build the app twice or more, and we can't use a mobile-specific framework and rely upon it for our desktop because they're just underpowered. So we need another option. And to find another option, we need to revisit the basics of, why did we get the idea that we needed a mobile-specific framework for our UI on mobile devices. And one of the main reasons that we have ended up with mobile-specific frameworks is that the very first iPhone interface, when we all saw it, it looked just completely different from the desktop. Everything was 3D, the metaphors for interacting with it were entirely different, and there was a lot of what we call skeuomorphism, which means trying to make things look like the real world and having UI that is a metaphor for the real world. Well, the industry has moved on from that. As a whole, skeuomorphism is dead or dying. If you look, for instance, at Apple or Google or Microsoft's direction, it's all unifying around a flatter look that is very similar on the desktop UI to the mobile UI. Google calls this material design, for instance. It's a single design language across desktop and mobile. It's a very flat look. Microsoft, you can see them taking steps with Windows to make it more similar to the mobile UI. It tends to focus on a single app at once. There's, again, that flat look and a lot of things being, a lot of design details and interaction paradigms being brought from Windows Phone into Windows. And Apple is also, obviously there was the enormous switch a few iOS versions ago from the skeuomorphic 3D look to a much flatter look. And they're doing a lot of subtler unification across OS X and iOS. So all the big players are on board with it, having a single design language and unifying the behaviors as much as possible. And there's an obvious reason for that. We're now seeing a lot of applications that have both a desktop and a mobile UI. And if they behave differently, if they look differently, then they're harder to learn because the UI just behaves and looks differently and the users can't use their skills across the two different classes of devices. So if we have a single visual design language across desktop and mobile, and if we want the behavior to be consistent wherever it can be, then that's one major reason that's one reason down for having a mobile-specific framework. It doesn't make sense from the point of view of creating a different look and feel or a different behavior. The other major reason why we ended up with mobile-specific UI frameworks is for performance. On the first iPhone, you had to tune like crazy to make a web app work at all. But this chart from the iPhone 6s launch shows that typical exponential performance gain curve. The iPhone 6s is up to 85 times faster than the original iPhone. So the performance landscape has changed quite a bit just in terms of the hardware. In the meantime, there's been a parallel trend with software optimization. So these are showing desktop browser engines, but it's essentially the same stuff under the cover. Going from 2010 to 2012, there was a 30x speed up in this particular JavaScript benchmark. This is just up to 2012. There's been a lot more improvements since then. And in addition to just JavaScript getting faster, the browsers now support a lot more standards that allow you to build leaner web apps. You can easily eliminate many more images. There's a lot of things going on at the HTTP level in terms of loading faster. So if you take these two trends, they're complementary. And you have an approximately 85 times hardware improvement with an approximately 30 times software improvement, the net improvement over 2,500 times. And it makes perfect sense that people would be skeptical that perhaps Apple's inflating their numbers for hardware or JavaScript benchmarks don't reflect real-world performance. If you throw in a healthy skepticism factor of 10x, you still get an overall improvement of over 250 times. And what that means is that something that would have taken 25 seconds on the original iPhone now takes 0.1 second on the most recent devices. So 0.1 second, if you know your HCI, you know that this is when the user perceives something as being instant. So something that was obviously unacceptably long, 25 seconds long, is now instant. This is an entirely new ballgame. So when we looked at this, and we got to thinking, why? What is it that we're trying to? What's the worst device we're trying to support? And we went back and we looked at our worst case scenario for desktop machines, which is IE8 on a 5-year-old inexpensive laptop, and maybe you have a bunch of people in a somewhat remote office that are all sharing a DSL line. And we compared that to the middle-of-the-road smartphone. And we realized that the worst-case scenario for desktop is worse than the middle-of-the-road scenario for a smartphone, because the mobile browsers provide this huge efficiency boost over IE8. The CPUs are no longer just completely different in kind. If you compare like a MacBook Air to an iPad, they are like much closer to the same ballpark because of all of the mobile optimization that the CPU manufacturers have done. And the differences in standard support more than make up for that difference in the CPU capabilities. And then finally, with the newer networks that are out here, LTE, et cetera, you often find that a mobile device has better access to the network than a bad network in a corporate office. So once we saw this, the other thing also is that there's a faster upgrade cycle for mobile devices. So you tend to have to deal with something that's 2 years old instead of 5 years old. So once we saw this, we decided that there really isn't a good reason to have a mobile-specific framework anymore. And we decided to look hard at how could we make our desktop framework able to scale down to a mobile device. How can we make that happen as automatically as possible? And what things would we need to have developers pay attention to as part of that transition? So we'll look through the challenges here. The first one, obviously, is the radically different screen size. Interactivity is also different in some obvious ways, like there's no way to do a hover because you can't tell the fingers floating over the screen, and also that it's harder to hit targets with your finger than with a mouse. You have much less precision. There are some look and feel differences that you have to get right. Most of them stem from the fact that you have a smaller screen size. And then performance. As I covered, the performance has improved radically on mobile devices, but they still have certain challenges that you need to address. So let's look through how we tried to solve each of these. First of all, for just managing the screen space at the gross level, we came up with a set of responsive layouts. These are layouts that react to the device class and use space efficiently, reorganize the UI automatically across desktop and mobile. There's a lot of auto-fitting that you have to get just right because space is at such a premium. We have certain components that just completely shift how they do their interaction for the mobile. They take over the screen, for instance, as opposed to just popping up in place. And then finally, intelligent data management. So one of the challenges on a mobile device is that the network may be fast, but every now and then you don't have network. You may be transitioning from like one Wi-Fi to another or from Wi-Fi to LTE, and you often get these little hiccups. So it's very important that any mobile interface you build is very careful not to make any unnecessary requests, because you can end up hanging the app for no particular reason just because you had a little network hiccup. Okay, so looking at the first one, responsive layouts, the idea here is to take the sort of large-scale structure of the screen of your application and restructure it automatically according to the device class. So you want, for instance, all 3 panes. If you have an application that involves 3 different panes, you might want all 3 of them to be visible simultaneously when you're on a desktop class machine, 2 at any given time on a tablet, and just 1 at a time when you're on a smartphone-sized device. So the idea is that this handles a common pattern that you see in a lot of different applications. You have a tree of navigation options, a list of items under that navigation option, and then some kind of a detail pane when you're drilling into the specific item. The classic example of that is iOS Mail, a mail application. Tree of folders, list of messages in each folder, single pane to view a message. And when you switch over from a desktop view like this to a tablet view, this is, for example, what iOS Mail will do on an iPad. You use a left-hand pane to show either the tree of navigation, in other words, the tree of folders, or to show the list of messages in the currently selected folder, and then on the right is always the detail pane that shows the currently selected message. Then when you shift over to a phone, the tree of folders, the list of individual messages, and the detail of showing a single message, each of them is shown just one at a time with slide transitions back and forth. So we captured this as a component that we call split pane. And you simply provide it these 3 screens, or also 2 screens, depending on whether you just have 2. And it reacts to the device automatically and displays them either side by side, or gives you a way to navigate between the different panes in your application. And when it gives you a way to navigate in between them, it also gives you the navigation bar, which is universally available on mobile, including details like giving you a back button to get back to the tree of options. And the great thing with this is that the way in our framework that you used to code 3 simultaneous panes, when you switch over to a split pane, the code actually ends up shorter, even though it's automatically adapting to the devices. We just found some economies of expression when we switched over to the split pane paradigm. And so it's actually easier to build a UI that responds differently on the different classes of devices than it was just to build the desktop UI now in the new version of our framework. Okay, so let's talk about some other individual components that need to behave a lot differently. For instance, the combo box. So a combo box on a desktop interface pops up in place under a text field. You dismiss it by clicking outside of it. We all know how this control works. If you look at the nearest equivalent interaction on a mobile device, things like searching in iTunes for songs, the search interface takes over the whole screen. You have a cancel button instead of clicking outside. So what we basically did is we made it so that our combo box control, when it detects that you're on a smartphone-sized device, just behaves differently. Pops up, takes over the whole screen, shows a different way of canceling, and replicates all of these behaviors that people are used to on mobile devices. And in this case, developers using our framework didn't have to do anything to get these new behaviors. They were already using a control called combo box item, and now it simply behaves differently. We did a similar thing with menu, which we'll show later. The other thing you want to do is, where possible, take advantage of smartphone-specific behaviors, such as the ability to pivot the device as a UI action. So we have a calendar component that looks a lot like Google Calendar or Outlook Calendar that you might be familiar with, the typical paradigm of a month, day, and week view. And just looking at the header area of a calendar component like that, there's not enough room to fit everything sideways on a smartphone. So what we did is we got rid of the tabs that allow you to go month, day, and week. And instead, you just have the ability to toggle between month or day and week. And then to go between day and week, you pivot the device. It's a very natural interaction, something that users, it surprised me to see that users just try to do it because they expect that they can get more information by turning sideways. And then there they are in the week view. So here again, this was an automatic upgrade for anybody already using the framework. The calendar simply behaves this way now when they upgraded to the new version. There's a lot of details you need to get right. This is a subtle one. So the spinner control, the standard desktop UI for that, is 2 tiny little arrows that you could only possibly hit with a mouse. If you try and hit that with your finger, it's very frustrating. When you are on a mobile device, it switches appearance to something that looks a bit like the iOS native control for a spinner. And another key thing is we didn't want to resize all the controls or make them look kind of Fisher-Price, Mickey Mouse on the mobile device. We wanted to keep them as compact as they were, but you need a larger touch area for a few different things, like the window close control. And so what we did is we implemented a behavior across a lot of different controls where the touch area is actually bigger than the control's visual appearance on the screen, which gives you this great advantage of everything is just as compact as it was before. It looks the same on desktop and mobile, but it's very easy to hit the controls. Users don't even really notice this. They just think that they are more precise with their finger than they actually are. Another thing you have to get just right, there are a couple things on mobile that everybody expects in terms of animations and transitions. This one is, let me just make sure that's actually animating. Yes. This one is the standard navigation bar animation that you see across all different iOS apps. Unlike a lot of gratuitous animations, this one has a very important purpose. It gives the users a mental model that something is sliding off to the left so that they kind of know that it is off to the left, and then it's natural for them to pick a control on the left to get back to it. So if you give users a spatial model like that, it makes it much easier for them to deal with an interface where they're only seeing one of 3 panes at a time, for instance. Auto-fitting. So space is at an extreme premium on a smartphone device, and there are some subtle details to get right in terms of fitting as much data on the screen as possible. So there's the concept of responsive design, where in many cases all that really means is that there's a threshold like 640 pixels, and at that threshold you show a different UI. Auto-fitting is a much more sophisticated behavior where you're reacting to the data dynamically rather than just statically changing your design at a certain pixel width. And an example of getting this just right is how we do auto-fitting to titles whenever we're showing a navigation bar. So if you look at these 4 examples here, we are taking a scenario where you have drilled in to look at a particular employee's data. In the upper left there, the employee has a fairly short name, and so the back navigation, which would take you back to the list of employees, actually says employees. Just below it, that red line is the center line. This employee has a slightly longer name, and you can see that it's been subtly shifted to the right. So there's a threshold number of pixels where we will shift it off-center in order to be able to maintain the full title. This is something that it's a very subtle detail that you'll see in iOS as well. Then on the right-hand side, there are 2 examples of how you can minimize the navigation in order to keep the title on screen. In the upper right, we've shifted to a generic title of back instead of employees. And on the lower right, we've shifted to just a left arrow. So getting these details right is extremely important in terms of allowing the user to have as much context about where they are in the app, because instead of having everything visible at once, they're sliding back and forth between a bunch of different panes. So you have to give them as much information as possible to help them orient themselves. And then intelligent data management. So this, again, is a special challenge in mobile devices. The network drops out every now and then, so you have to be very careful about not loading any data that you don't need. We do a lot of things in terms of minimizing round trips to the server. We will perform filter and sort operations on the device whenever that's feasible, whenever the data set gets small enough, and I'll show an example of that shortly. And then just making maximum use of advances in browser technology to minimize the number of media files that are actually downloaded. This is things like using spriting to use a single composite image across a bunch of different controls, and also using technology like SVG to render some of the little glyphs and things that you need in the UI so that it doesn't load a separate image for that. Okay. So we're going to show a demo of some of this stuff. Okay. So previously, when we were looking at the desktop capabilities here, we were in this example browser. This same example browser is also available on mobile devices, and it's actually an example of using our split pane capability. It's built with the split pane that we were talking about. So if I select a particular example, I moved from the example tree on the left to the tab set, which is just like this tab set you can see in the background, to view the example, and then I have back navigation to get back to the sample tree. So this is an example. This is you can go to SmartClient. This happens to be running on my machine. This exact example tree is available at smartclient.com, and you can see this paradigm in action by going to it with a desktop browser and a mobile device at the same time. I mentioned menus. So here again is an example of a component that automatically adapts to the mobile interface and pops up full screen instead of popping up inline when you're on mobile, and then does slide transitions to get to submenus, including automatic back navigation. So this is one of the things that was an automatic upgrade. We have already seen combo box, calendar, and spinner. So the other thing that I wanted to talk about was some of the intelligent data management features. Okay, this is something we call adaptive filtering. So what's going on here is you have an inline filtering interface in a grid. And what you want to do, and you have a large data set. Down at the bottom, it shows that there are 3,959 rows. And if we start to type in a filter, at this point, there are only 46 matching rows. Now, since we have all the matching rows loaded, it would now be safe if the user filters further to just do the filtering on the device. And that's exactly what happens. There's no longer a server round trip going on here. Now, if I start deleting my filter string, I'm still doing local filtering because it's more restrictive than the last time I loaded data from the server. But if I finally delete one more character, then it automatically goes back to the server. So we have this same behavior. We have this behavior for filtering. We have this behavior for sorting, and it requires no developer effort. You just set up the data connection, and this is an automatic behavior. This is really key, again, because you want to be able to minimize network usage, both from the point of view of scaling the app, minimizing the number of times you hit the database and hit the application server, and from the point of view of not locking up the app for an unnecessary data request. One more aspect of that is what we call automatic cache synchronization. This one I'll show on desktop. So this is an application that basically allows you to edit a bunch of office supplies that are in a kind of a stock catalog. If I go down here and I edit the SKU on this item that I selected, watch up here. So if I do that and save it, the grid automatically responded to the data that the form saved. So this is another built-in behavior that you don't have to code that avoids the very common thing you see in applications where whenever data is saved, the entire data set is reloaded in order to show the screen again. By updating the cache in place whenever possible, we avoid a whole other set of data loads there that both slows down the scalability of your application and also can result in an unnecessary request that is a major problem when you have a network hiccup. Okay. So who's using this? Well, we have a lot of customers in the Fortune 500. We have a lot of customers in particular verticals here that you can see. And largely because this was an automatic upgrade experience for anybody who simply moved to the next version of our platform, this is already deployed very, very widely. And in some cases, we've had the somewhat funny experience of running into a customer who is asking us, how do I start building a mobile UI? And we just tell them, have you actually tried accessing your app in the new version with a mobile phone? Ta-da. So, everybody needs to make a few tweaks, but it's surprising how much automatic adaptation is possible. And especially if you're starting from scratch with a new application, we have a relatively short document that's part of our reference information that explains the few things that you need to consider to make sure that your mobile UI works well. Okay, so last few things to cover. This framework allows you to write either in Java or in JavaScript. One is called SmartClient, that's the JavaScript version, and the other is called SmartGWT. It uses Google's GWT to allow you to write the UI in Java. In both cases, we have an optional Java server framework. We have both LGPL and commercial licenses. The LGPL framework gives you all the UI components. The commercial license gives you the server components as well. There's obviously you can download the open source version for free. There's a full-featured 60-day trial of the commercial version that's available at smartclient.com. All right, so I'm going to open up for questions a little bit. Does anybody have one right off the bat? Come on, the presentation can't have been that complete. Somebody's got, okay, there we go.
What is the server component?
The server component basically gives you an automatic connection to SQL, Hibernate, JPA, or any kind of custom Java data model that you have. So, for instance, if you are using the UI components only, then the most common way to connect to the server side would be to build a REST interface that the UI can call. And we can also adapt to WSDL, we can adapt to a pre-existing REST interface, or give you a protocol to just implement. If you have the server-side component, then that entire piece is automatic. You can show us, for instance, a JPA bean, and we will not only provide a data connection to it, but we will automatically configure UI components from it. So for example, if you just tell us that you want to define a data source that accesses this Java bean, then you can immediately bind a grid to that Java bean. You will see all the columns that correspond to the fields on your bean with intelligent things done about titles, like if the property is something like employee, then it'll be lowercase, then we will capitalize it, and we will take a guess, right? So often the grid is immediately configured to be useful against that bean, not only in terms of showing the correct columns, but also in terms of it instantly being able to do data paging against it, filtering and sorting both server and client side, updating records. You can simply turn on inline editing, and that will save changes to the bean that you're connected to. And then a similar thing for forms. So the form will likewise show a series of fields for editing the component, automatically choose appropriate editing controls like dates, date fields for date fields in Java. And then in both cases, you can customize the binding at any granularity without losing any of that automatic editing. So you can say, oh, well, for this one field, for instance, it's an integer field, but I actually want to use a spinner control here because I know the range is very narrow, right? So you can just say, I want a spinner control for this field, and all the rest of the automatic generation and automatic behavior still work. Then there's a bunch of details like being able to export to Excel immediately. Yeah. But that's the key, instant connection to your data model. Yeah?
Is it possible to extend building custom components?
Uh-huh, yeah. Basically, whether you're working in Java or JavaScript, the UI components are arranged into a typical inheritance hierarchy. So for instance, the tree component is actually a subclass of the grid component because it can show multiple columns and it just has some differences in how data binding works. And then you can extend further from there. You can build a custom component that composes the existing components or just changes a lot of their behaviors. There's a huge range of custom components that people have built at our customers. We're always kind of amazed at their ingenuity in terms of all the things they've been able to build. Is there another one over there?
Yeah, does your platform support auto-sizing to go along with terms of auto-fitting concept you introduced earlier? What I mean is that when you're on a desktop, you can afford to go smaller on the rows. When you're on a mobile device, you probably want your columns or rows to be higher, so if people are scrolling and trying to they don't fat finger.
Right. A lot of that happens through correctly manipulating the viewport. Yeah, so usually you don't have to do something like have a different setting for row height on the grids for desktop versus the grids for mobile. That's like one of the primary things we want to do is make it so that nobody ever writes code. If I'm on an iPad, use this setting. If I'm on mobile, use this setting, right? And yeah, that's primarily done through the viewport. Yeah. Anybody else? Yeah. Oh yeah, no, I mean that's arguably primarily what we do. Basically, the industry as a whole is still taking a bunch of older desktop applications and moving them over to mobile, right? And there have been over the years, first it was things like CRM that went, and then more and more sophisticated applications have been able to be ported over to web technology and made available on mobile devices. So that's kind of like our primary focus. Does that answer your question? Or okay.
Actually, I would ask about pros. Does this mean that the legacy applications will be rewritten using this framework?
Yeah, we don't have anything like taking a Delphi application, pressing a magic button, and having instant web interface. We do see other companies advertising that stuff, but if you get into the details, it doesn't really work. So you do have to rewrite it with our technology. We maximize how much of the existing infrastructure you can save by being able to connect to like just about anything. But ultimately, there is no like snap your finger solution. It's more of a matter of enabling you to build it in the new technology as quickly as possible. Any other questions back here? No? Okay. And we are at 4. Okay. One last thing. If you come visit us downstairs at booth 15, we are raffling off an Apple iWatch. So come get scanned and see if you can win a watch. Thank you all for coming. Oh, sorry, sorry to cut off the applause. One last item. We have data sheets over here and some USB keys that you can take home that have that information on it. So you can take a look at that at smartclient.com, or it's on the keys for you. Thanks for coming.